Well, we know that a disaster recovery plan cannot be trusted until it's been tested. The idea why we do the test is to find the gaps, find the flaws, to verify that the time frames we've set for recovery are realistic. Testing also helps us to train our personnel, that they become familiar with their role in a crisis. And it'll help us now when we run a test of our DR plan, quite often to check, are the configurations of our equipment set up correct? If we are using an off-site location, is the equipment at that off-site compatible with my systems and applications? When we create the disaster recovery test, we obviously want it to be thorough and complete. We develop a set of test objectives. What do we really want to test in this test? Quite often we'll test our plan in different stages for different types of events. Obviously, we don't want to actually cripple the business doing a test. So therefore we get proper approvals and seek to ensure the test is scheduled at a time where we'll minimize the potential disruption to the business. We then execute the test and see what the results are. We evaluate the results, and from that we should come with recommendations of what we can improve on. Were there any files or configurations, for example, missing? And from this, of course, we seek to improve the plan. That every time we'll try to have a better plan than we had before. Now when I test, I can do just a simple checklist. Give a copy of the plan to some of the relevant managers and have each one look it over and just check to see if it's still up to date for their department. We could also do a structured walkthrough, or sometimes called a tabletop exercise, where we bring our key people together and we step through a scenario as if it was a real disaster, but all we're doing is sitting around a table and discussing each person's role. We can do a simulation. For example, a common simulation is to pull the fire alarm and see that everybody evacuates the building properly. A simulation is where we actually try to run, for example, a realistic test to make sure that people know their role and responses. Now, if I have a backup site, then it could be that I could actually run in parallel at that backup site for the day. This especially works with a hot site, but not with a warm site. And a parallel test is I would load my data out to the hot site, and I would actually run all of my systems at the hot site in parallel then with my primary sites, just to make sure that everything worked correctly. Hopefully, you don't have to do a full interruption. A full interruption is where we actually do cause a outage so that the things will fail over to an opposite, should we say, processing capability. But that's always high risk and should only be done, of course, with the consent of management. So our test strategy is start small and then become a little bit more complex. Remember, when we test, also test what would happen if my key people weren't available. We want to make sure that we're ready for that. From every test, apply the lessons we've learned so we can be better at preventing, detecting, and recovering from a disaster. And always communicate with management. Let them know that we're alive. Let them know that we're testing. Let them know the results so they're able then to support and know that the actual disaster recovery planning effort can be trusted. This is the end of Chapter 4. The operations, maintenance, and service domain. In this chapter, we've looked at several areas with information systems, the operations end of things, the maintenance of our systems and change control, and service management. We've looked at various types of system components that make up our systems, and now here we've also looked then at system resilience, building our systems that are robust and will continue to operate despite the challenges they may face on a daily basis.